Hey everyone, welcome to part 3 in my series, What I Think Every Adult Should Know About Science. In the first 2 videos in this series, we've been talking in a kind of static way, building blocks. This is what stuff is made of. But things change and move around, and if you've noticed, stuff happens. So in this video, we're going to start to talk about what's going on at the smallest atomic level when that stuff happens. Stuff is happening in your body. What's going on with these atoms? We're going to start exploring chemical reactions. What does that mean in terms of atoms? My name is Chris Dingman. I am a private tutor in math, science, writing, and SAT, ACT prep. All my info is linked down below. Let's go. All right, we're talking about matter, what stuff around us is made of, the basic building blocks. And we've talked about how those basic building blocks are found in the periodic table, which is right here. Here are the basic building blocks of all matter, all stuff around us. And all those building blocks are made up of just 3 basic particles: protons, neutrons, and electrons. And once more, stay tuned at the end of this series for the surprise, bizarre revelation under all this stuff. But right now we're talking at a certain level, everyday level. So here's a diagram showing what I just said. The smallest level we're going down to is protons, neutrons, and electrons. You look around you, and that's the only thing that everything around you is made of. Those 3 little interchangeable building blocks. Just those 3 things arrange themselves into 92 different kinds of atoms, which is like a little ball of certain number of protons, neutrons, and electrons found in the periodic table, those different kinds of atoms. And then those 92 kinds of atoms arrange themselves and connect to each other to form thousands and thousands of different arrangements, which we call molecules or sometimes crystals. It depends on how they get together. So this is very much like letters. There's only 26 letters in the alphabet, but we can form thousands and thousands of words just by rearranging those 26 letters. It's a similar concept here, except at the basic level, we've got only 3 letters, so to speak: protons, neutrons, and electrons. And then you could think of maybe the atoms are words and the molecules are sentences. Similar thing. Out of a very few elements, we make a very complex world. And I was talking about this in the last video. I was showing you that here we have just 3 basic atoms: oxygen red, carbon black, hydrogen white. But when you arrange them and stick them together with other atoms, you get very different substances. You can stick 2 oxygen together and get oxygen gas. You can stick an oxygen with 2 hydrogen and get water. You can stick 2 oxygen around a carbon and get CO2, carbon dioxide. You can stick a bunch of oxygen, hydrogen, and carbon together in a big old mess like that and get table sugar. Now, the next big concept, and this is very big in terms of just understanding science and the world around us, is something called chemical reactions. Because chemical reactions, you can even forget that phrase. The concept really is all these atoms can be rearranged, and they constantly are rearranged, right? So for instance, the carbon that is in sugar, after you and I eat that sugar, digest it, we breathe out that same carbon atom in this form. So our bodies are rearranging the atoms. That's going on all the time, everywhere. Every living thing in every one of its trillions of cells is doing millions of chemical reactions right now. There are untold trillions of chemical reactions going on in your body right now. All our cells are furiously and incredibly complicatedly rearranging atoms to make different substances out of other substances, to burn fuel. And on that note, every time we burn fuel, whether it's a piece of paper or a piece of wood or coal or gas, we are doing a chemical reaction. We're rearranging atoms. Right? In our laboratories, when we invent new things like new material, like let's say nylon, back when nylon was invented, that's the rearrangement of atoms. Right? We're not pulling new things out of thin air and making this new substance, say nylon. We're taking materials and we're rearranging the atoms into new arrangements. So for example, water could be split apart. We could cut this and cut that, and we could get these two hydrogen off together and bond those two together. And then if we did this with another molecule, those two oxygen could get together and make oxygen. So we can take water, and we know how to do this, and we can isolate the hydrogen from that. This would be now hydrogen gas, two hydrogen atoms stuck together, and oxygen gas. And this process is relevant now because hydrogen gas is actually a good source of energy. You might have heard of hydrogen cells. So we humans want hydrogen gas right now. We would love to find a way to make hydrogen gas in large quantities because then you can use it as a fuel. And one of the ways to get hydrogen gas is to do what I just told you, which is basically to chop up water into its parts and get the hydrogen gas from that. So again, in everyday processes, all we're doing is rearranging atoms. That's what our bodies do basically to live. My biology teacher in college, he came out the first day and said, "What is life?" And one of his answers was, "It's a shit sandwich and it's always lunchtime." And his other answer was, "It's a big bag of chemical reactions." That's what keeps us going on the physical level. Just a huge, big, incredibly complex orchestra of atoms rearranging themselves. And it's just beyond imagination. Now, I didn't pick these particular molecules, particles here, at random, because these are actually incredibly central to our survival and the survival of all life. So let me show you what I mean by that. I'm going to rearrange these things here. All right, so now I've got oxygen over here plus, now I chopped off half of that sucrose molecule to make another sugar that we call glucose. You don't need to worry about these names. Just basically it's a sugar. There are different kinds of sugars. And then over here we've got our old friend H2O, water, and carbon dioxide or CO2. Now, what I've shown you here is the central chemical reaction, or one of the central chemical reactions. Probably if I had to nominate the chemical reaction for all of life, it's this. Oxygen plus sugar makes water and CO2. What's the big deal about that? Well, it's not that we want to make a bunch of water and CO2. It's not that we're all excited about making water and CO2. It's that this process releases energy. And that energy is what makes all living things go. So you're looking at a really, really fundamental chemical reaction, and it's called cellular respiration. This is happening in the cells of every living thing on the planet. There are a few bizarre bacteria that are an exception to this, but plants, ants, mushrooms, people, raccoons, birds, amoebas, we're all doing cellular respiration. Aside from some what we call anaerobic bacteria, we're all taking in oxygen, we're all making glucose or getting it somehow, and making water and CO2, But the reason we're doing that is that process releases energy. Cellular respiration is actually about getting energy out of this fuel source, and releasing it so we can use it. So I can blabber away at you right now. All right, now I'm going to give you another basic chemical reaction to all of life. So I'm going to rearrange these again. What did I do? I just swapped what side they're on. So now we've got water plus carbon dioxide giving us oxygen and sugar. Well, where did you think we were getting that glucose and oxygen from? It wasn't coming out of thin air. It was coming from these guys. What's doing this process? Well, plants and algae. This is photosynthesis. Photosynthesis doesn't give us energy, it takes in energy. Where does that energy come from? That energy comes from the sun. So photosynthesis is the reverse of cellular respiration, and it's a rearrangement of water and CO2 into oxygen and glucose. And the sort of point of photosynthesis is to capture energy coming in from the sun and stick it in that glucose. Glucose is like a battery. Food is basically, in part, a battery, a storage of energy that we can then use when we want to. So we're going to talk more about energy and all that soon, maybe the next video or the one after that. But I just want to show you two really fundamental chemical reactions that are central to life and emphasize that they are rearrangements of atoms. So much of what we hear about and do in our body are chemical reactions. And in these everyday chemical reactions, the thing is that we're dealing with the rearrangement of atoms. We are not splitting the atom, so to speak, okay? So we're not like taking an oxygen atom and cutting it in half. That involves nuclear processes, and then things get kind of hairy. Atoms can sort of split apart. We'll talk about that in a future video. But in everyday processes, besides in a nuclear reactor or a nuclear explosion, we're not talking about splitting atoms or getting inside of atoms. We're just talking about rearranging atoms, right? The 108 or so basic atoms, we're just rearranging. All right, so I know in another video I said 92 elements. Some of these elements are man-made, some of them are really rare. The man-made ones only exist for like a fraction of a second in some particle accelerator somewhere. I don't know enough about that stuff, but basically there's around 90 to 100 common types of atoms. And the main point of this lesson is that a chemical reaction is just rearranging atoms in different combinations. So none of these guys here are being violated in any way. In other words, say you got boron maybe is combined with, I'm just making this up, with carbon, and then they split apart and boron comes over here and combines with chromium, or maybe there's 6 of these with 3 of these and 8 of these, and then they react with 2 of these bonded to one of those, and then these guys come over there. It's a rearrangement. You get the picture. So let's talk about, and by the way, all those things I just circled are just random, probably don't normally happen, or quite certainly don't normally happen. But I wanted to just mention a few other common chemical reactions in everyday life besides these really fundamental ones, the cellular respiration and photosynthesis. And just a reminder, cellular respiration, it's called cellular because it's happening in every single cell of our body and every single cell of every living thing. It's so amazing and wonderful that this connects all life. We're all doing that same process to get energy. And only green plants are doing the photosynthesis part. So it's only green plants and algae that are making that glucose, that basic fuel that feeds all life. So what are some other common things that are chemical reactions or rearrangements of atoms? Well, all burning is a chemical reaction. The technical word there is combustion. And cellular respiration is actually technically a combustion. From a technical point of view, we are actually burning food in our cells, but it's a slow burn, which is a good thing. Other kinds of burning, anything from burning your toast to burning wood in a fire to burning coal to burning gas and oil to burning methane to burning natural gas. Burning is a chemical reaction, and we tend to burn things that have carbon atoms in them, bonded to various other things, which are hydrogen and oxygen and some other things. And those are rearranged, as we saw, into generally smaller things. CO2. We get some carbon monoxide in some burning, and we get water. Okay, another common reaction is rust. Rusting of iron takes iron atoms and combines them with oxygen from the air or from water. Here's two oxygens stuck together. And it actually combines them. I'm not going to write the official formula, but it's basically iron is symbol as Fe, it's Latin. Now the iron is actually connected to some oxygen atoms. Sea creatures with shells make something called calcium carbonate to make their shells. And they take calcium atoms and they combine them with CO3. It's floating around in the water, so that's a carbon connected to 3 oxygen. Again, don't take these things I'm writing too literally. It's like I don't know that that's the arrangement, but the basic idea is that there is a rearrangement going on. So the calcium is combining with the CO3, and it's making something that has a calcium stuck to the CO3. And then one more very important chemical reaction is hydrogen gas, which is 2 hydrogen atoms stuck to each other. And that combines with nitrogen gas, which is 2 nitrogens stuck together. I'll make the nitrogen yellow. Now, I put 3 lines there. Don't really worry about that. That's just kind of how strongly that they are connected to each other. Nitrogen happens to be very strongly connected, the 2 nitrogen atoms in nitrogen gas. So we call this H2, and we call this N2. Those are the chemical formulas. And those rearrange to make ammonia, which is NH3. So that's going to be a nitrogen atom stuck to 3 hydrogen. And that really is, by the way, what an ammonia molecule looks like. And that reaction is important because it's a step in the process of making fertilizer. The ammonia is used to make fertilizer, and that's important because all living things need nitrogen, and we get it ultimately from plants. So the plants are going to have to take that nitrogen, that N in the NH3 molecule, the N atom in the NH3 molecule. We all need nitrogen, so plants need to have the nitrogen in the soil to take it up and then offer it to other living things like us. Okay, I think in the next video I'm going to start talking more about energy, a fundamental concept in understanding the world. And I hope I'll see you in the next video, or you'll see me or hear me or something like that. Remember, I do tutoring online anywhere in the world. My website is achievewitheasetutoring.com, and I'll link that down below. I tutor all math up through calculus, as well as biology, physics, chemistry, writing, and I specialize in SAT and ACT prep. Okay, ciao for now.